Hello everyone. So as I said, this video is continuation to the part 1 of program 1. So the program 1 is all about print all reachable nodes from a given starting vertex using BFS traversal technique. Correct? So we were already discussed in the previous video how algorithm works along with the example. Now, we'll be going to write a source code using Java programming language, and we'll be going to see how input and output works for the algorithm. Now, let's understand step by step. So, as the question says that we have to read a graph first of all. So, graph is what it's all about, vertex and edges, correct? As it is graph representation, we cannot put into the program. First point, you cannot put the graph as it is. So you have to think about what are the ways to represent graph. So there is one way which is putting the graph into matrix, adjacency matrix. The other way is adjacency list. So in the last video, I explained about adjacency metric. Now we'll be going to write the code for the same. Fine. Now look at the first statement in the coding part is taking the initial package for all Java programs. Now, so the next is what? I'm just writing a class for BFS reachable, and make sure the class name should be your file name. I have given BFS reachable.java and the class name is what? BFS reachable. So what is the algorithm? Your algorithm is take the number of vertices first. And the next is read the adjacency metric. So these three statements are what? Input statements. Before you write a program, you have to be sure to think about what is the input of the program and what is the output. In between, the procedure or the process will comes, correct? So the input is what? These three lines are the input. And this line is there, no? This is what? Output of the program. So how I know output of the program? Read the question for twice. You'll understand what you are going to achieve through the program. So output always will be our question. Input always will be in the question at least a part. Correct? Now, so as I said, these three statements are input. This statement is output. Now, to achieve this output, I have to follow the procedure. The procedure is what? Apply BFS, breadth first search. One of the graph traversal technique. Now, so the second statement is what? Read the number of vertices n. Now what are the statements helps me in Java to write the source code for reading the n vertex. So n is what? My integer number. It can be of 1, 2, 3, 4, 5, any number. So I wanted to put n is equal to integer number. Hence I can take a data type of integer number. So these are all the statements of Java programming language to read one number. So I'm just taking scanner class, scanner sc, new scanner system.in. I'm just giving the input to the class and my input will get stored into n variable. Which data type n variable is? Integer data type. Now n is settled. That means executing or writing the source code for this statement is completed. And look at the algorithm. What is the next statement? Now you have to read adjacency metric. For metric, you know that two variables, correct? Row variable, column variable. For that is the reason I have taken two for loops. Look at two for loops. What these two for loops indicates that this first for loop is for row, second for loop is for column. So put together, this will be a two-dimensional array with the size of n into n. If you don't want to take a rectangular matrix or a square matrix or equal size of rows and columns, you can also change it. So I'm just taking graph. Now look at this. In which way I'm representing the graph? Adjacency matrix, I said no, initial of this video. That's what I have taken, two-dimensional array representation. Now, so graph I by j is equal to scanner next integer. Look at these statements helps us to read two inputs. One input is for number of vertex and the other input is for adjacency matrix. And there is one more statement to take the input. What is that? Read the starting vertex or read the starting node. If number of vertices are represented in integer, what is the data type for starting node? Integer itself. Now take that one, enter starting vertex. Hence, all these three statements are input. And you can keep this in your mind as long as you are writing graph programs. Maybe it is BFS, maybe it is DFS, maybe it is Hamiltonian cycle. What kind of graph programs maybe? For all the graph programs, if you take graph representation is two-dimensional array, these steps are common, very common. You can write these steps for all the programs wherever you are representing graph in array or two-dimensional array. Fine. After this, what is our algorithm? Our algorithm is, here it starts. Mark all vertex as not visited. Now take a variable. Visited new boolean is my variable. So this variable initially is what? I do not visited any kind of vertex. My first vertex is my visiting vertex. Hence, visited array started with what? First vertex. Now, whenever you visited that vertex, that will be updated into the queue. You are adding one element. Which element it is? Starting vertex node. That element we added into the queue. Before you take queue here, queue has to be defined. Look at this. Queue has to be defined. And now your queue is running. You can add on the elements once after you are exploring the vertex. Now in which vertex you are? You are in starting vertex. So after you are in starting vertex, what you have to do? Until queue is empty, you just repeat the same thing. What the same thing is? Exploring the vertex. Fine. Exploring the vertex is what? You have to visit that starting with 0 until you reach to the last vertex. You have to check this. What this one? This is having the vertex edge is 1. That means connection is there. Connection is existed in between two vertex and that vertex should not be visited yet. Okay. So this is the common principle in the graph. So I told you the first three lines are common for all the graphs. In the same way, this is the common principle to traverse the graph. So what is the common principle? Edge should be existed and before earlier you should not visit it. That means unvisited. And when this condition is true, that means we are visiting it. And you can add on to the queue. That's it. So until this loop will run until queue is empty. So this is how your queue runs, this logic. So this is what the first program that we were printing all reachable nodes from the starting vertex. Now let's see. I'm just executing this program. Enter number of vertex sum. I have taken 5 as my number of vertex and we'll just go ahead with the same thing that 0, 0 to 1, 0 to 2 is there, 0 to 3 no, 0 to 4 no, and the next row it is 1 vertex to the 1 to 0 no, 1 to 0 is no, obviously 1 to 1 will be also 0, no cycle loops, and now 1 to 2 is also 0, 1 to 3 there is a edge, and 1 to 4 no. The next row it is for 2, now 2 to 0, 0, 0. I wanted to put an edge from 2 to 3. Now put it as 0. Now this is what? 0, 1, 2. Now it is 3. look at the first row is about 0 at the vertex. That means this value is 0, 0, this value 0, 1, this value 0, 2. 0, 1 is 1 means what? Edge is there. 0, 2 is 1 means what? Edge is existed. 0, 3 is 0 means what? No edges existed. In that way you have to understand. Fine? And 1 to 3, 2 to 3 and 3 to 4 will give. Just check. And we'll just keep remain all zeros because I don't want to put any edge from fourth vertex. Now, starting vertex I am choosing as 0. Now, reachable nodes are 0, 1, 2, 3, 4. Let's say, if I wanted to know the connectivity among the vertex. So, for that I can write the other program to know whether the graph is connected or not. So, this logic will help you to print the reachable nodes from the starting vertex. So, that's it. Thank you all.